simplify that as 1 minus sine squared theta equals cosine squared theta. So when I see a 1 minus x squared, maybe you can think back to this equation, which you can rearrange to this, and motivate that substitution. You might think, well, that's a lot to ask. That was the last thing on my mind looking at this integral. And I suppose it is the last thing on your mind the first time you do it. It's the last thing on your mind the second time you do it. And it's the last thing on your mind the third time you do it. But the first time you did it, you were in Calc 2 class. The second time you did it, you were in Calc 2 class. This is now the third time you're doing it. So yes, it's still the last thing on your mind. But I'm saying by the time you do it the fourth or fifth time, it's no longer at the bottom of your mind. It's now it starts to rise from priority number 175 to priority number 121.
There was no priority.
James is saying it wasn't even on the list.
No, too long.
All right.
There's that hole back there somewhere.
Black hole in the brain. All right, so we'll try replacing x with sine theta. So I'm kind of giving away what the trig sub would be. That's going to be our substitution. Now, if we're using any substitution, whether it's U substitution, trig substitution, now we proceed the same way. Once I've decided that x is equal to sine theta, I need to figure out what dx would be. So if x is sine theta, what would be dx? I can't remember where I left off. So let me just reset to Zach. Yep. So dx would be cosine theta d theta. And now I will substitute that in. So I have the integral from 1 to x. Dx has been replaced with cosine theta d theta. And x has been replaced with sine x.
Oh,
James.
question. Well, why would you subtract sine squared theta? You know, like why wouldn't you subtract cosine
Oh, I could.
squared theta?
If I did this exact same problem, but I used the substitution the other way, it'll work out just fine.
Okay.
Okay? So there's absolutely no difference.
All right.
Actually, it's just a touch easier if I'd used cosine instead of sine.
Back to your integral over there. Should that be sine squared theta?
Yes. Okay. Maybe now you can see where the good news is with the substitution. 1 minus sine squared theta is otherwise known as what? What can I replace that with?
Cosine squared theta.
Cosine squared theta. What's the square root of cosine squared theta?
Cosine squared theta.
No, square root
Wait,
of cosine
what?
squared. The square root of cosine squared.
Cosine.
Just cosine.
What did I say?
Cosine squared. Okay. It's all right, James. I just put an x there instead of a theta.
Yeah.
Now I do
My mistake.
cosine divided by cosine, and cosine divided by cosine cancels out. So I get the integral of d theta from 1 to x equals the square root of 3 dt 0 to t. Okay, Max, the right side.
Oh, that would just be t. That would just be t.
T times square root of 3. Okay. Now this is a little tricky. It's actually not that Vaughn can't do tricky things, but
Don't you have to
we
go
need
back into theta form?
this will be the integral of d theta is theta,
Going to be inverse.
and x goes from 1 to x. I can't go and put the 1 in for theta. These limits were for x, not for theta. So to make that crystal clear, this is for x going from 1 to x. That is not for theta going from 1 to x. So before I put my limits in, I have to go from theta back into x. And that's the point. Go ahead.
Inverse sine of x.
So I'll replace the theta
Inverse sine of x.
with sine inverse of x. So if x is sine theta, theta is inverse sine of x. So theta is sine inverse x, 1 to x, equals the square root of 3t. out of space, but I've got maybe 2 more steps to do, but we're almost done. Now I plug in my limits, so we get sine inverse of x minus sine inverse of 1 equals the square root of 3t. Sine inverse of 1, you of course could do with your calculator. But what that's asking is, sine of what gives me 1?
90?
90. So I have sine inverse of x minus 90 degrees equals the square root of 3t. I'll move the 90 to the other side. And as I write here, I'll make sure I block the camera, so if any of you want to look back later and see what I did, that way you can't tell. I'm joking, but this looks like just the way I'm writing, I'm kind of writing.
Yeah. Well,
Plus 90 degrees. And then finally, to get x by itself, what should I do to both sides?
Sine?
Sine. Yep, apply the sine. So finally, I'll get x equals sine of the square root of 3t plus 90 degrees. The answer there is anything but stunning, because we had a mass on a spring, and what's it going to do? It's going to boing, 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 go back and forth. In fact, sometimes in engineering, you can motivate your substitution. We knew we had to somehow solve this integral. But if we had a hunch that the answer was going to come out as a sine or a cosine, that you're perfectly fine to use your hunch of what you think the answer should look like to make a substitution that seems appropriate. I've now got position as a function of time. Would it be difficult to get velocity as a function of time?
Just take the derivative of that.
Take the derivative. Would it be hard to get acceleration as a function of time?
No.
No, okay. I've got 7 minutes. I'll put a target up on the board for the computer exercise. Let's do session 12. And Andrew, right? Andrew, why don't you join? Are you logged in? Brian, are you logged in?
I can't see. I see
Ryan's already got it.
Wait, no, I need to add.
Chair and join Ryan down there.
I have to add.
hey, you pass there.
I have to add.
You know the cheat to the backpack?
Probably.
Where's the cheat supposed to be?
Professor,
Yeah.
would you mark off credit if it were x equals e to the I radical 3t plus 90?
I mean, I don't mind.
Well, e to the I and sine aren't quite exactly the same. In circuits, we were using that, but we were doing the superposition. We were adding in this extra piece and then subtracting it off at the end.
Okay.
So I would probably put a smiley face on it and maybe take off like half a point.
Okay.
Because it wouldn't technically be.
Gotcha.
Oh yeah.
All right. Cool. You were.
I'm looking for that.
Did you lower the security settings?
Lower.
You gotta do something kind of this.
Explorer. Copy, paste. I don't want the portal. 17:30.
Session 12. Team Awesome.
Gold team rules.
Okay. Probably, I don't think the plug, like a flash drive. The plug, I think, just is.
No way. It's really bizarre that somehow I have to go to settings for now. Join on the
We're in
What exact same thing? Like,
It's fine. We're in
session 12. on Max. Max can run here today.
Alright, ball is going straight up, show the picture.
Is that 0 though?
See, one dimension.
So it says assume that
Zero.
assume up is positive
Mhm.
and the origin positive 0. Point and the ball just thrown. At which point is the total distance traveled negative?
Negative. Oh, okay. Z. Yeah.
Add. This is 0.
No, you're right.
I thought it said no, yeah.
At which point is total distance traveled negative?
Which point is the position?
Yes.
Oh wait, is that like a top of a hill or something? Because if that's it, then
Oh,
this is
so
the ground,
it's
and that's what
physically
it
moving that way. So it never
Wait, but
went
it
back.
says assume up is positive and the origin positive 0 is the point from which the ball is thrown.
So why?
Alright, let's redo that. At what point is the magnitude of the velocity the greatest? Ignoring air resistance. It'd be a
The
D.
greatest.
So you would
Oh,
if
D-
it's
D-
gravity
D-
down
D would
at
be the
its
greatest.
highest velocity at that point.
I trust me, I don't know why.
No. It is the greatest.
I was worried about the first question.
Yeah, I'm still thinking about the first question.
I think this is the first one. Roll straight up where it's shown in the picture. Assume positive of the origin, positive 0 from the point which the ball is thrown. At which point is the total distance traveled 0?
What is velocity the greatest?
I think they may have
None.
just settings.
Oh, because it passes that point. So at that point right here, right?
Yeah.
That's when it's 0.
Yeah. The ball is
No,
shown in the
velocity is
picture.
positive, it's
Positive,
physical.
blah, 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 blah. At which point is the position negative? D. Ball shown straight upwards as shown in the picture. Assume positive, positive, or negative. Blah, blah, blah. At which point is the magnitude of velocity the
Velocity is negative. That's C and D because
the magnitude of the velocity?
So it's
B.
gotta be B,
It'd be
right?
B. It'd be 0.
Wait.
let's slow it down.
Oh yeah, the small is right.
Also not blah 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 blah. At which point is acceleration
But it's
negative?
Yes, wait. So I'm thinking about acceleration.
It's
C.
One piece at a time. When is the velocity?
No, but
B,
that's.
C, D. All of them.
Oh right. Negative 9.8. Yes. Good.
When is the
Oh, we're
magnitude of
done.
the number?
We need 10 remaining. The elevator is moving upwards and speeding up. Which is bigger? The force? Oh shit.
Oh,
Yo,
here
there's
we
an
go.
elevator question, Roger.
Elevator.
The velocity is negative 3, but say what's the magnitude of it?
What do you mean?
At which point is the magnitude?
I don't know what that is. Bro, it's just. I'm not telling you.
We could have left those behind. People weren't on my little
No, that's the
still getting these balls.
position of it.
I probably got 1, 2.
The force of the elevator.
I'm never
the
ready.
cable
Bro,
on
I'm never ready.
Elevator.
Okay.
elevator. Oh, I think this one is neither.
The elevator is moving upwards, speeding up. Which is bigger? The force of the
Neither.
cable on the elevator or
Roger.
the elevator arm?
Roger, your favorite question
Neither.
is the
Yes.
Yeah, money. Person.
Yo, the elevator, man.
Neither.
That's
Neither.
Wait. Don't rush it.
Neither. Neither. Get it. Okay. These okay. Position, time. Okay.
How far total distance is
Assume.
For example, if I start here, and I go from here 2 meters over, and then 2 meters back.
So it's negative
So 1 over 1 is just negative 1.
negative 1.
If I change in position, it's 0.
So this is position versus
Think of
time.
total distance traveled as the odometer reading in your car.
Determine the object velocity. This distance over time, right?
Distance traveled.
Object velocity.
So, and the distance
It's a constant velocity.
It'd be 3/4.
We'll have lost choice. Which of them is
negative 1.
1/10.
So it's a little. Okay, but it's negative.
We'll see if this is 0. We're going 1, 2, 3, 4, 5. So 1, 2, 3. Be 3
No, but
fifths.
it's when it's t equals negative 1 second. negative 1 second.
The velocity is always the same.
Right.
It's a straight line. Its velocity is always increasing.
All right.
So it would be rise over run. So it'd be 5/3.
Okay.
So it's 5/3.
0.75.
You got it.
0.75.
Well, I just want to make sure.
Yeah, go ahead.
10 meters per second.
5 fourths, you said, or 3 fourths?
5/3.
Oh, 5 fourths.
Right? 1, 2, 3, 4, 5. 1, 2, 3.
No, that's 4, bro.
1,
It's not zero. It's not
4,
zero.
5.
Yeah, but
No, but it's from here. 1, 2.
oh, okay.
The terminology
Wait, why is it from there?
Oh,
Because
Oh, right, the line. Okay.
but yeah.
They intersect. Why intersect? Yeah.
yeah, so he's going
Two questions.
1.667 meters per second.
Yeah, you saw. The blue line on the grid represents an object's velocity. If we think
It is right.
the blue line on the grid velocity.
Let's find out why.
Oh, you're saying
Oh, we did seconds per meters.
Velocity
That's
is
why.
increasing.
God dang it!
There is an acceleration. So the acceleration force. So it's 1, 2, 5, 6, so 10 over 6.
sometimes people use
Divided by 6.
sometimes it's this homegrown software.
Rise over run. Right.
What?
So it's 0.6. 6.
Wait, it's 1. It's, yeah, it's 1 over. Yeah, because it's rise. You went down 1. It's negative 1 over 5. Rise over run. Look at it. It's 1.
Per second.
I'm like, what the hell is that?
I did 5 meters divided by 1 second.
No, you don't do run over rise. It's rise over run. So it's negative 1 divided by 5. That's all right. No, no.
There's none there on the order line, so the only one that would be 0. We know, yes.
We got down to 10. They just marked me down.
So what did you
What am I
do
going
now?
to go do with my
I
life?
didn't rise over run.
I'm guessing the boat didn't come in that needs to come in today. So I could just do that.
You want another one?
Actually, I'm waiting for one to find it.
That's it. That's it. 10. We got 10 rounds. 10 remain.
So
I'm just here at the store.
we have 14 remaining.
Hang in there.
Oh, okay.
They're all quick.
Oh, I thought it was. Yeah. No.
No, I'm it's for one of my customers. We've been waiting for it to come in forever.
1.5.
Fair enough. Because that's kind of you had the right thought. So just wanted to do this. I'll help you
Go
out.
back to work.
Question to get determine the output acceleration.
I think I might. I should. I need that.
The velocity.
Do you materials?
Wait, why does it ask if you,
Acceleration.
When you
in terms of this relation,
have like
you got
constant
it.
velocity.
outside or something.
Velocity.
No, wait, no. That would be a straight line.
At what point do you
Right.
So
So
it would be,
a volume in it?
it's negative 4.
I'm gonna have to ask.
Just type and then.
Because I did it,
Rise over
but I
run.
could be doing it wrong. I'm not sure. I took that like
no, but it's
0.4 meters per second squared.
A long time ago.
no, but it's asking for acceleration, right?
Yeah. 0.4 meters per second
Okay.
squared.
I thought you took it last year. I think you took it a year ago. I thought.
Oh, maybe it was
Yeah, you took
my
it.
third semester.
No, you're taking it last.
thing's
It was
still
last
recording.
spring.
Trying to find acceleration.
Yeah, it's a little hard to find.
Yeah, you can scroll through by.
Yeah.
Did you find the link for where the videos are?
Oh, is